Welcome again to a new video number 3, and this is the last video for chapter 5 lesson 4, sum and difference identities. So in the previous two videos we learned how to evaluate and simplify actually trigonometric functions using sum and difference identities. In this video we'll learn how to solve trigonometric equations using sum and difference identities. Alright, but before we get into this lesson, we have some practice exercises I told you to do in the last video, in video number 2, which were to find the exact value of this expression and to simplify this expression. Okay, now cosine 7 pi by 8 cosine 5 pi by 24 plus sine 7 pi by 8 sine 5 pi by 4. This is cosine, cosine, sine, sine. So this is the identity of cosine a minus b or a plus b. Now because I have plus here, so it's minus a minus b, and this is a 7 pi by 8 and this is b 5 pi by 24. Okay, so all we have to do now is to evaluate this what I have inside the parentheses. 7 pi by 8 minus 5 pi 24 by 24. I need to take a common denominator. 8 24, I need to multiply this 8 by 3 to make it 24, so I need to multiply up also by 3. So what I would get here is cosine 7 pi times 3 is 21 pi, 8 times 3 is 24, minus 5 pi by 24. Okay, now 21 pi over 24 minus 5 pi by 24, we simply subtract the numerators, which is 16 pi over 24. Now 16 pi by 24 can be simplified into, this can be divided by 8, so this would be 2, and by 8 3. So cosine, we would be left with 2 pi over 3. Cosine 2 pi by 3 from the unit circle is over here, 2 pi by 3. Cosine is the x value of this point, or the x coordinate of this point, which is minus half, minus 1 over 2. Okay. As for b, tan 6x minus tan 7x over 1 plus tan 6x times tan 7x. Also this is tan a plus b or tan a minus b. Now because I have minus sign here, so I need to have a minus sign over there. So tan a minus b, a is 6x, b is 7x, so 6x minus 7x. 6x minus 7x, we can subtract this and we would get tan minus x. Now tan minus x, if you can remember the even odd identities, sine of minus x is minus sine x, cosine of minus x is cosine x. We have tan of minus x is simply negative tan x. So this expression is equal to negative tan x. Okay? So now let's see example 7, which is the last example in this lesson. And in this example you need to find the solutions of cosine pi by 3 plus x plus cosine pi by 3 minus x equals half on the interval 0 to 2 pi. Okay, now here I have cosine a plus b and here I have cosine a minus b. So let's apply the sum and difference identities. Cosine a plus b is cosine cosine minus sine sine. So I would have cosine pi by 3 times cosine x minus sine pi by 3 times sine x. So this part is for this term. Now plus, we get into the second term. Here I have cosine a minus b, so it would be cosine a times cosine b plus sine a sine b, and this is all equal to 1 over 2 here. Okay? Now, if you look at this expression, we have two like terms here with opposite signs, so of course we can cancel them out. And then I would be left with cosine pi by 3 times cosine x plus cosine pi by 3 times cosine x. So this would be, if we add those two, we'll get 2 cosine pi over 3 times cosine x equal to 1 over 2. Now, cosine pi by 3 can be evaluated also. We can find its value from the unit circle. Pi by 3 is over here. The x value, because we are finding cosine, is half. So this is 2. Replace cosine pi by 3 is by half. And cosine x is over here. This is all equal to half. So 2 times 1 over 2, this is 1. So we can cancel this out. And I'm left with cosine x equal to half. Now where is cosine x equal to half? From the unit circle again, half is here for pi by 3. Also, I have another point which has an x value for as 1 over 2, which is this point over here, 5 pi over 3. Okay? So I have two answers in this interval. From 0 to 2 pi, I have x equal pi by 3 and x equal 5 pi by 3, which solve this equation. Alright, again, finally, practice. You solve this alone. Cosine x plus pi minus sine x minus pi equal to 0 on the interval 0 to 2 pi. Again, follow the same procedure to find the value of x. Here I have cosine a plus b minus sine a minus b. So just replace each expression by its identity, and hopefully you'll get an answer. Thank you very much, and it's over for this lesson. Thank you.